Hello, everyone, and welcome to this amazing another episode. And today we'll be learning about Opstrace. My name is Sayam Pathak, and I'm a CNCF ambassador working as Director of Technical Evangelism at CIVO, building the next gen cloud native service provider. So thank you all for tuning in today. And those of you who are new to the channel, please care to subscribe. And if you are watching on Twitch, then please care to follow. So really excited for today's stream because I really get excited when I see such solutions out there. So Opstrace, it's kind of a complete solution, complete monitoring solution that you will get packaged with the awesome open source tools that we'll be seeing throughout the session, and how you can use it, how you can use the power of Opstrace, and so on. So I'm very excited for the session, and I hope you are too. So yeah, please be nice to each other in the chat. That's the only thing I would say. And obviously say hi, hello, where you are joining in from, which time zone you are joining in from. That would be nice to hear. And today I'm joined by JP and Seb from Opstrace team. Very excited to have you both because they are the maintainers. They have been building this product from scratch and thinking about the solution. So it will be very exciting to hear what problems they were facing and what exact solution they are coming up with. So I'm really excited about that. So over to you folks. Please introduce yourself to the community.
Cool. Thank you very much, Sayam. I'm Sebastian. I'm the CEO and co-founder of Opstrace. My other co-founder couldn't make it, but we are here with JP. JP and I have been working together for a long time, even before Opstrace. We'll talk about what we've built and why we've built this. Definitely. Before Opstrace, I worked at a lot of different companies. Originally, Solomon Hikes and I started .cloud, which became Docker. So that's kind of my claim to fame here. And so it's always about making technologies easy and democratizing them for people who don't want to learn everything about them. I'll turn it over to you, JP.
Okay, yeah, my name is Jan Philip. Okay, I'm usually known as JP in an English-speaking environment. Thanks, Seb, for handing over to me. So I'm a passionate software engineer, but actually by education, I'm a scientist, a physicist, actually with a PhD. But after that, I really wanted to go into software engineering. And my first gig was actually with Seb at Mesosphere, where we tried to build the data center operating system. And then I joined Seb as the first employee/engineer at Opstrace, end of 2019. And this got us here.
Cool. Awesome. Should we jump right in, Sayam, about Opstrace?
Yep, I was just finding my mute button as always. Today we'll be discussing obviously all about Opstrace. What is Opstrace? Why it exists? What are the problems the people, awesome people that you see on the screen are trying to solve for you in the cloud native ecosystem? What are the features? How it actually works? And JP has promised that there's a cool demo as well. So we'll be having that. And yeah, we'll be in the end also touching on the roadmap and getting involved section, which is very important because when the products are niche, I mean, that's a very, the quality of the product is good. So a little community push can take it to the next level at a very faster pace. So the acceleration would depend on the community adoption and the issues that we file, how we contribute back. So all those things. And let's get started. Like, what exactly is Opstrace?
Cool, thank you. I couldn't have said all of this any better. So Opstrace, my co-founder Matt Appelman and I started this. So we got the idea around summer 2019, where we started asking around a lot of companies, and we wanted to help, again, building something in the infrastructure space. Infrastructure software is our bread and butter. That's what we've always been working on. And we wanted to, again, find a place where something was very hard and how to make it available to a lot more people than they can. We asked a lot of companies and a lot of users, and we discovered that observability and open source monitoring was not a solved problem yet. While we loved things like Prometheus, we loved all the CNCF tools that existed and that were sprouting from all sides. they require experts. That's it. And you can become an expert. Everybody can become an expert. It's not like something complicated, but it requires time. It requires knowledge that you need to acquire that you don't necessarily want to when you are trying to solve your own problems, your own systems. And especially monitoring is something where you want it to work all the time, every day, and you want it to be something that you can rely on, like because you're actually keeping your own product alive with these kind of things. So Opstrace, after a lot of different iterations, we wanted to build a SaaS that kind of runs in somebody else's network. We didn't want to have the data. We didn't want to have to get people to pay for every single byte of data that they send us. And then over the years, as we built the solution together with people like JP, the idea matured that we were actually standing on the shoulder of giants. And it was also a good idea to open source this. And so we went this route. We decided to create a complete solution. We don't build databases. We rely on existing databases like Cortex and Loki and potentially others in the future. What we decided to focus on was automation and user experience. How do you actually democratize all this so that you can actually use this and so that it's as easy to use as some software as a service solutions, right? They're not that easy, but something like Datadog allows you to just connect an agent and get started. That's the experience we wanted to replicate for everyone with open source software. So how do you make open source software as easy to use as possible monitoring open source software, observability open source software. And that's how we got to it. Opstrace is basically, we call it a distribution because we put one version number around many other pieces of software, and we ensure that they are tested, that you can completely trust and upgrade from one version to the other. Because as many of you experts out there know, it's hard. Like when you use open source software, you need to test it somewhere. You need to make sure it works. We do that for open source monitoring. We package it. We put the UIs like Grafana in front of it. We add our own UIs for administration, and we also add our own APIs wherever needed. But we give something that out of the box is secure with TLS and authentication. Often in open source, it's left as an exercise to the user, which is great, but that's again a learning curve. And then we put a version number, like I said, around it. We test it at scale. If you look at our blog posts, we started with smaller scales, and now we're testing this at things like 200 million active series. And that's it. That's what this is. Making sure that it works out of the box, that it's secure out of the box. And more importantly, create a solution that everybody can run in their own network. And when we say network, we talk cloud account here. So AWS and GCP is what we support. You take a very simple CLI and you start deploying Opstrace, and it deploys the entire stack inside of your cloud accounts. I'll let JP will talk much more about how it works in detail. But yeah, so I talked a little bit about the motivations, how we got there, and for who it is. It is for everyone who wants to monitor and not pay crazy prices for their monitoring. We can, this is, if you do it this way, thanks to the technologies that arrived in the last 5 years, matured in the last 5 years, like Kubernetes, you can actually run a stack that is much, much, much cheaper and has way, way more features than you would get at a SaaS provider. So that was our idea, and this is why we started this. I'll turn it over to you to ask JP about that.
Awesome. So I think that's pretty decent introduction. We all know Datadog, like how it works and how expensive it can get very quickly. So seeing the open source solutions with the latest in the cloud native software, which are becoming stable, getting to the maturity level and adoption wise, Prometheus is there. So we have all these Loki, Cortex. So all these are getting mature day by day, production ready. People are using that in production actually. So wrapping something around that, around all the awesome open source tools that people are already using, and creating a complete a solution, I think that's really fancy. And I really like the idea, like how people would be able to use that with their existing clusters. So I know you mentioned like AWS and GCP, but I would assume it would be able to work with any Kubernetes cluster that you are running with, and you can apply the manifests and get the whole stack deployed
If I
onto.
may reply to that one, like this is actually like a very, very common request, and of course it's a very a very understandable one. There is the challenge. So in fact, we use cloud provider bits and pieces like a database, or in fact object storage and persistent volumes and all these things, and actually rely on their properties, including their robustness and availability, right? And so that actually makes it easy for us to build a system that is pretty robust and also highly available. If you take these bits and pieces out of the picture, it becomes much more difficult. Basically, do something for bare metal or any Kubernetes cluster like a K3S1. We have explored that, tried that. It's probably it's a definite thing for us to do at some point, but it's really challenging.
Yeah, exactly. We decided to have something that spits up the entire infrastructure, and while it comes at the cost of customizability, which is your own Kubernetes cluster, what we want to guarantee is that the stack stays up, right, and that it doesn't break, and especially between upgrades. So that's where we are right now. These are the compromises. But like you said, we're very interested in hearing from people who want to use it in different manners, and then we can learn to figure that out.
Yep, absolutely. That makes sense. Because you want to package everything, you want to have it at a production ready scale, obviously at all the scales, starting from small to large. So you need some of the software which are resilient, you need some of the services which are resilient, and not letting to rely on the user to create, because that again then becomes manual tasks for those users to again configure something, and it do not becomes a complete package. So that makes sense to have the cloud provider integration, and I think there's no harm in that. But yeah, down the lane, there can be a version that can be just installed with your Kubernetes clusters, and you can play around with it, and you can just improve the features. Yeah,
for sure.
I mean,
Yeah,
I'm definitely interested with that. But yeah, I would also ask like the community to just have your words and make them do that, and also contribute.
Yeah,
for sure.
We're clearly open to this. Yeah.
Awesome. So what are the features, like how it works, how Opstrace would work?
So I would actually mention so many things, like the philosophy and where things are supposed to go. I would like to kind of provide a very simple view on Opstrace as you can look at it today, and really feel like, okay, I understand what this is. And I think it's you can fairly well describe it as a storage system, right? Opstrace, you actually deploy it into your cloud account, and the goal is that it gives you some API endpoints where you can push your observability data to, like logs and metrics, and then it stores them for you, and then you can query them back, right? And beyond that, of course, there's many more finer-grained features, right? For example, around the security of these API endpoints, and of course also alerting and integrations. But at the very high level, Opstrace is a storage system, and deployed in your own cloud account using the credentials that you use, for example, for AWS or GCP. And from here, I would actually like to start the demo and really go very, very slowly through how you actually deploy Opstrace into your cloud account, and which choices you have when deploying it. So I've actually prepared an environment, so I'm not completely reliant on this to work and actually finish in time, because this will take like easily 15, 20, or 30 minutes. But I will nevertheless start from scratch by downloading our latest build from main, actually, and with a simple curl command here, downloading our latest Opstrace CLI. And I hope you can all see the screen, and let us know if it's too small or so. Downloading the tarball and extracting it. So this is our CLI as the entry point to everything we do. Here on the right-hand side, I've opened our configuration reference, which describes the different configuration parameters you can choose upon installing Opstrace into your cloud account. Okay, now I have this here, right? The binary, the CLI. When you run it, of course, you have to provide some arguments. One of the operations is actually create. So let's do create. Still missing some argument, right? Yes, of course, it wants to have some additional details. What we want to do is we want to create an Opstrace instance. We call this instance into AWS, and we want to give it a name. And the name I'm choosing here is Playground 2, because the actual thing that I already created before is Playground. Okay, so this will also fail because it needs a cluster configuration, or say, terminology is hard, instance configuration. And this is, I've prepared one here. This config.yaml file, let's have a look into this file. Okay, this is now already, a very important and simple thing to look at to explain fundamental concepts around Opstrace. So first of all, and I make this maybe even bigger. First of all, we're choosing for 2 tenants to be provisioned in this Opstrace thing upon install time. We call these tenants red team and blue team. And some of you might be familiar with multi-tenancy from different contexts. Others may not be familiar with that. So tenants are really just a way to organize things. And you can think of this as teams or prod and staging, or anything that you want to use it for organizing your environments, or also isolating your environments from a security point of view. And in Opstrace, this specifically means for any tenant that you provide here, you get distinct DNS names pointing to giving you access to ingest API, but also for every different tenant, you get distinct authentication token that you have to use to actually send or query data. So another really important thing in this configuration file is this piece. So by default, we always use Let's Encrypt certificates. By default, we get them from the staging environment that browsers and clients don't trust by default, right? So here I specifically choose to use Let's Encrypt production certificates, so that once this thing is installed, that you can actually visit the UI and send data using your system's certificate authority store, so the browser trusted certificates. I've also chosen, to put this thing into an AWS region that is a little closer to me than, for example, anywhere in US or India. So just that, latencies are not too bad for the demo. And I've just chosen an instance type that is a little more beefy than the default, but that really doesn't matter too much for this demo. Also, I've chosen for this Opstrace instance to be comprised of, after all, 5 virtual machines, which is also not too important for this demo. Okay, but this is now the input for the create operation. And now I'm starting this, so the goal is not to complete this one, but we can see an important concept. First of all, and I know this is big for everyone to see this now. First of all, it tells you, which AWS credentials it actually uses, right? It discovered them from my home directory. Then here it gives you a point to hook in and confirm something that it would actually be doing. So this links out to a set of mutating AWS API calls. So, before this would actually create costs in your AWS account and, create all these different cloud resources in your AWS account. This is just to give you an idea what this thing is doing to your AWS account, just, for us to be a little responsible here. So you can review this, there's things like create a VPC, right? But then there's also create DB cluster. So, it's creating a database. It is also, of course, creating an auto-scaling group with the actual VMs, right? And you can just review that and just, very deliberately have this thing use all these API calls by confirming with yes. Okay, and now this is actually starting the setup procedure, which is actually going through our DNS service where you have to log in. And this is now where I'm actually stopping this. So from here up to completion, this would actually take like 20 minutes. By the end of this procedure, what you have is a DNS name, which is playground, the name of the thing you've chosen, .opstrace.io, which is based on magic that we provide. And this then actually brings you to the UI of this Opstrace instance that you just installed into your own AWS account. Now, this is already logged in. I could log myself out to show you the login process again, which is not necessary. This is like single sign-on through auth 0. Because I logged into this before, it didn't show that. Okay, so like we've already seen like super important concepts, right? So you download the CLI. This discovers your AWS credentials, or of course you can also GCP, and then you choose a few important parameters around your Opstrace instance, and then you install this into your cloud account, and then you can visit the UI and actually get started. So getting started means many different things to many different people, but one very, very obvious thing to do is now to actually send some logs or metrics into this Opstrace instance. And to make this as easy as possible, I actually want to see the sidebar. Okay, here we go. We have started putting this idea of, okay, I'm lacking in this Zoom. I'm lacking the tenant selection in this. Here we go. Okay, I wanted to quickly show this before. Here in this, before I zoomed in too far and this thing here in the top left disappeared. This is actually now giving you a drop down where you can select the active tenant. And as you can see, there's 3 of them right now. And so there's the blue team and red team, from the config file. You've seen that before. And then there's a third one, the system tenant, which is actually our way of collecting and exposing the system internal metrics and logs. So for sending data into this Opstrace instance from a outside log source or metric source, you would now maybe want to use the blue team or the red team tenant. And then I'm just picking one of them here. And then you would have a look at the integrations tab in our UI for you to get an idea of the kind of pre-built integrations that we have selected for you. So there's different categories, like 2 very obvious ones is, when you have Kubernetes cluster that you actually want to monitor, you can use the Kubernetes metrics or the Kubernetes logs integration here. Both are built in a way that you would have to pick some details here, and I'm actually doing this walkthrough quickly now. So I actually have prepared a Kubernetes cluster behind the scenes to do this. So what we want to do is we want to send metrics from this Kubernetes cluster. Or maybe let's start with logs. This is a little more interesting to browse. So what we want to do is we want to send logs from this Kubernetes cluster into this Opstrace instance that we have deployed. So we give this thing a name, logs from Kubernetes cluster, and we press install. Now what this is doing is generating the Kubernetes deployment manifest YAML file for us, which we can download. And as you can see, I've done this before. So it's giving us this YAML file. So I'm not downloading this again. So I have this here in this directory. It's this file. And it's also giving us the command to actually run this. So you notice there's and I hope you can see that, it's a pipe kube control apply -f. Let's maybe quickly double check that kube control is actually connected to something. And it is. And I can just tell you that the kube control in this shell is connected to a Kubernetes cluster I have deployed on GKE. What we can do now is just take this command and paste it here. And take a breath, because before I'm actually running this, which would then deploy a daemon set onto this Kubernetes cluster, with Promtail processes, which would collect logs and send it into the Opstrace instance. Let's quickly look at the dashboard here to see that no logs are incoming right now. I'm doing this, so I've selected this red team tenant here, right? Going to overview and then logs. So, and in this dashboard, you can see that there is, without going into all the details of the different panels, what you can basically see is that there is no activity at all for logs. This dashboard is, in this UI, is actually shows a time window of 24 hours. And this is maybe just a little too wide. So I'm going, just ignore this, but I'm going to show the same dashboard now really in Grafana, which is happening now, to just, zoom in a little further in time, so to say. Just going here, dashboard.
One thing I want to add while JP looks for the dashboards, the reason for our Opstrace admin interface is because one of the big problems is when you arrive and you deploy such a thing, it is, what do I do next, right? What's next? How do I connect my cluster? Of course, the advanced person can ignore all of that and start just configuring Promtail or things like this, but we wanted to do something for people who didn't know anything about these things. And we wanted to guide them into, this is where you can go to the Grafana for this tenant. This is where you can see the logs. This is how you connect a cluster. So this is just the beginning of really adding very easy to use functionalities that people who don't know much about Kubernetes, and we encountered a lot of these people who use Kubernetes, but they don't know much about how to connect logs and metrics. And we wanted to make that easy for them, right? And while staying completely configurable and completely transparent to the advanced user as well, right? That's the compromise is, don't break things for the advanced user, make it easy for the easy user, for the beginner user.
Right. So I'm basically showing this again. I come to the UI. Here's the getting started view, and I actually press the create the Kubernetes logs integration button. And I press install here for the logs. I'm just doing this again, log.com cluster install. Okay, this is embarrassing.
No, it's a known bug. We need to fix
it.
You already created an integration with the same name, and we should put an error message there. So there, we can do it. If somebody else wants to do it, welcome. So you can go to the integration and install it, and you can find it there.
Yes, exactly. Yes, okay. Because I realized I actually have to download this thing because it is the red team. So, okay, so what I'm doing now, I'm now actually instrumenting the source of logs with this with this set of deployments, and you can see it's actually doing a bunch of things, right? It's deploying a secret in a service account, and then after all this, kind of the core piece here is a daemon set, so running on all the nodes of this source Kubernetes cluster. A thing called Promtail, which is actually the log aggregator from the Loki ecosystem, which is after all parsing all the log files on the machine and then watching them for changes and then constructing the binary messages and pushing them out to Loki. In our Opstrace instance. Okay, so now we're waiting for a magical thing to happen, actually. now what we're looking at here is a dashboard that gives us an insight into Loki's point of view for the red team tenant. And so now we're just starting to see that data is coming in. So here on the right-hand side, we see a panel showing active number of streams. So streams is just a different word for, different logs, log streams, actually log sources. So it was 0 just, a few minutes ago, and now it's like, a small number. We also see that actually, these this data is communicated with HTTP requests. Here in the top left, we see the HTTP request rate. We also see how long it takes for these HTTP requests to be processed. Just a very high-level overview of how it looks like from Loki's point of view, that there are now these logs being pushed into our direction for the red team tenant. After all, we see that data is incoming with this panel. We can start querying this data now, which is what I'm going to do next. For this, I'm just going here to the Grafana Explorer view, select logs as a data source.
You're still in the system tenant, though.
Oh, yes, thank you.
My pleasure.
Yes.
So this is a multi-tenant system. The system tenant is the built-in tenant that watches the system itself. So what JP was saying, this was like dashboards for Loki itself, and now he's moving to the red team tenant, which is the one where the data from that cluster is getting sent to.
Right. So I should zoom a little bit into this. So what we can see here, this is actually a set of different labels that we can pick from. So with that, we can already see that the data is incoming and makes a lot of sense because there's, Kubernetes specific things in here. I'm now going to select namespace Opstrace because this is known to contain the logs of the individual promtail processes that actually run on each of the machines in a log source cluster. Well, none of this really matters too much right now, but you can see that this is actually the log output of the individual promtail instances running on the log source Kubernetes cluster. We're not going to do anything with it further, but after all, this has already demonstrated quite a lot that we just are pushing our logs into the Opstrace instance. And what I've not explained a lot about so far is that this happens securely. So maybe going back to this piece again here, where we actually made the deployment on the log source environment. Like this secret actually contains an authentication token, and the URLs used in this, maybe we can look into
maybe show the YAML.
Yeah.
So this is the generated YAML that people could build themselves too.
So here you can see this URL. It's HTTPS, and as I've pointed out to you guys before, like the certificates presented on the endpoints providing this are actually using a production environment. Let's encrypt certificates. So what we're doing is we're sending an authentication token over a properly TLS secured connection. So in this case, this is really a GKE cluster running in GCP, pushing logs securely through the internet into an Opstrace instance running on AWS, right? And I've basically only shown simple stuff, but this is actually, getting here is actually already hard with bare bones open source tooling, right? To establish this communication channel securely between different clouds is just one example to, I think, show the power behind our approach to building an observability distribution. Okay. Now we've been sending logs from this Kubernetes source into the Opstrace instance. Like we could do the same with metrics, which is almost boring to show right now. But what this would do, it would just generate a YAML file that after all deploys a Prometheus in the Kubernetes source cluster, and that Prometheus would scrape all the well-known endpoints and then push the metrics into the Opstrace instance. So it's actually pretty easy. It's actually pretty easy to grab observability data from a Kubernetes environment, and this is also kind of the most obvious way to kind of immediately get value from Opstrace. You can add it to your infrastructure if you run your services on Kubernetes in your production environment. It's actually pretty non-invasive to just get started with Opstrace. You deploy these well-known and established log and metrics collectors at the source and let them push into your Opstrace instance. Okay. So what else do we want to show? I can actually show something that demonstrates our Datadog API, or we can
maybe show first, go to the integration panel. Can you go to the integration panel? I would like to say a few things about that.
For sure. Wait a second. Starting fresh.
So basically, we understand that not everybody necessarily has Kubernetes clusters. And even if you have Kubernetes clusters, there are a lot of things that are not necessarily in there. So we started putting other integration, what we call integration there for things like Amazon CloudWatch, Google Cloud Monitoring, or even Azure, right? And what these buttons are is Prometheus has exporters to go scrape CloudWatch, to go scrape Cloud Monitoring. So we're taking those open source exporters that exist and we're making them easy to use. And what happens when you click install on one of these buttons is that after you provide the configuration, right now it's still the raw configuration that you have to learn, but we'll make that easier. Once you deploy these things and you click install, for example, on Google Cloud Monitoring, it will deploy an exporter inside of the tenant that you're in the Opstrace instance that will go to your cloud account and scrape that. And we also provide a management for the secrets that are needed for this, right? You might need to add credentials to collect CloudWatch. You might need to add other credentials to collect Google Cloud Monitoring. And then you might have multiple accounts on Amazon, multiple accounts on Azure. This is how you can centrally collect these things and get them into Prometheus, into Cortex in our case, and go query them back without having to install anything on your own clusters, because we believe very strongly that you shouldn't put your observability stack as much as possible, even in the same region, right? Like if possible. It's all a cost thing. Maybe you want to put in the same region and in a different AZ, but ideally it's somewhere else. It's in a different cloud provider, because when your region is going to go down, you're going to want to know. You're going to want to have all the observability information still there. So that's why we're building the system where very close to a Datadog, I don't like to do the comparison all the time. We even strayed away from that, but very close to these kind of SaaS providers where you can just start monitoring various things. That's what we're trying to do with these integrations. And you can also do all these things by hand if you're an advanced person. One more thing that I would say, JP is currently showing, for example, the Datadog API. That's an example that we built to be able to ingest Datadog metrics. So these are other ways that we want to help migrating over to things like Opstrace. I'll let him describe this.
Yeah, right. So there's many things we could show still, but two interesting ones I can basically offer is demonstrating our Datadog compatible API. Where I can show that we can just run a Datadog agent locally on my machine here, and it will actually push data securely into the Opstrace instance. Another thing that is super interesting is that I at least want to briefly mention is that with Loki and Cortex, especially the experts will know that there's there's so many things you can configure about them. And for many of these things, it actually makes sense to be able to change them during runtime, because it's just difficult to anticipate all the characteristics of load, for example, or all the meaningful limits on things. And it just makes so much sense to be able to play with these parameters in a really playful fashion. And we've just built an API and also a UI around changing the runtime configuration of Cortex and also Loki. So I'm going to start with the Datadog part of this, and after that, if we still have time, I can also show the runtime configuration. Okay, but first the Datadog API. So I'm actually, I can just say this. We have a nice blog post, I think, about this online. I'm just kind of following my own instructions there. First I'm just I'm setting two environment variables that the Datadog agent actually respects. And the one is this one here. And, instead of pointing it to Datadog, I'm just, pointing it to, this is familiar to you, right? Red team.playground.obstrace.io. And then this is new, like the DD dot, right? So this is one of the things you get out of the box, right? So this DNS name is pointing to the Datadog API of this Opstrace instance. And then we set this environment variable, and the content is actually the API token for this specific tenant. Okay, now all we need to do is launch a corresponding container with the Datadog agent. And as you can see, there are these two parts here, where we pass on the two environment variables. This is actually not needed. Okay, let me quickly modify the command in another editor.
It is not needed because this is just a way for clusters that have staging certificates. In this case, we have production certificates,
right?
Which are valid all over the internet.
So I have already started the Datadog container, and it has a lot of log output. So what we're doing now is, so the Datadog container is running on my machine here, and it's sending whatever it wants to send through the Datadog API offered by our Opstrace instance into this Opstrace instance. And so there's, for those that are familiar with the Datadog agent, it collects, many different pieces of information about the system that it's running on. So what we can do now is just have a look at one of the metrics, one of the many metrics that it measures. So I'm back into the Grafana UI that is specific to this red team tenant, and I've chosen as a log source metrics here. Now,
in case it wasn't clear, while JP searches for it, every tenant has their own Grafana instance, right? So we deploy a Grafana instance for every single tenant in our system.
Right. So yeah, and as we just see here already in this kind of label browser, we see all these Datadog specific metrics pop up. So we see this is we already got confirmation that this is working. Now we can pick anything. What is interesting? So in this blog post, it shows actually this. It's just a system metric about the bandwidth through your networking device. And of course, we can maybe pick. You can already see there's my machine has a bunch of useless and virtual networking devices, and only one of them you can maybe see in this plot is actually making sense and showing some data, probably related to whatever we're doing here, like video streaming and keeping up this communication. So that already should demonstrate how easy it is to maybe get started when you are in a I don't want to say legacy environment, but yeah, when your environment actually uses the Datadog agent and you're worried about, changing everything at once, of course, rightfully, you might just want to just restart your Datadog agents, and instead of, having them send their data to Datadog into the Opstrace instance. And of course, if this is a really critical production environment, then you might actually want to kind of duplicate that, but this is a different topic. Okay, so I think I'll have 2 minutes to quickly show this runtime configuration piece, which I actually find super, super useful. Okay, so back in the main UI here, we can select, again, one of the tenants. I'm picking red team. And now I'm going into this cluster admin section here. And I press configuration and then Cortex. So Cortex, again, for those people in the audience that are not too familiar with everything we talk about. So Loki really is for ingesting logs, and Cortex is for ingesting metrics. And so now we can change configuration of Cortex for a specific tenant so that the configuration changes apply at runtime. Might sound super, trivial, but this is something that is a little more difficult to achieve when you are using vanilla Cortex. And just for those of you who don't know how many different configuration parameters there are, just to give you an impression, there's a bunch of them, and this is only a subset, really. What you can do now is you can say, so some of the labels here are not yet, units are not shown, but this really means you can set, you can limit the red team tenant to ingest or to send at most 100,000 metric samples per second. Or of course, you can now change this to 5,000, just, if for whatever reason that makes sense to you, and then, just applies at runtime. And this is actually super powerful. Different kinds of limits you can configure here, but also, other configuration parameters.
Yeah. I want to add something while you're here, I want to add something about this. Right now, this is quite raw. We just expose it. We expose a little bit of help for each of them. But our goal here is over time to get to what we call bounded configuration, where we're not going to allow you to set it to arbitrary values depending on the size of the Opstrace cluster itself. So that you don't break it, so that you don't add, for example, too high of an allowed ingestion rate when your cluster wouldn't be able to handle it anyways. Right now, we took the approach of just exposing it because we like taking things iteratively and do it piece by piece. But over time, we want to actually guide and help the user to not break their own cluster. This is what we're about, right? Like, don't let the user break their own system.
Right.
That's it.
Maybe regarding actually seeing some interesting load. Like we play a lot with synthetic data generation, and then of course this is actually how we test our system, and whether playing with limit makes a lot of sense. Like we have 12 minutes left for everything. We can finish the demo part, or I can show some synthetic log load being emitted into this Opstrace instance as we wish. It wouldn't really show anything new anymore, but we could still do this.
Yeah. I think it's go ahead, Sayam. Sorry.
Yeah. So just wanted to get some of the things clear. So we have Opstrace solution, and Opstrace get installed on right now, as of now, on 2 cloud providers. So it's basically downloading the CLI. Then we have the config, Opstrace config, that we have to provide with the certificate and some of the configurations of the cloud provider, and then we need to install that. So it will create the full Opstrace cluster, and it will have all the UI and all the components integrated with that, with the right set of parameters, right set of tooling, which is their database is connected, and all those stuff. And then there are integrations with which you can keep sending the data to, Opstrace. And now here my question is like we generate, like we have the Kubernetes integration, and you showed that we can have a YAML file generated with respect to the logs and the metrics. So I believe that YAML file at least can be run on any Kubernetes cluster, and you can flow the logs from that Kubernetes cluster to your Opstrace cluster. Yeah, we agree that Opstrace cluster lives on a certain cloud provider, but you can have your existing Kubernetes clusters send metrics to that Opstrace instance of the cluster that is running.
Yes.
Is that right?
Yeah,
That's correct.
This is perfectly right, and this is also, how it makes sense to look at, any of this architecturally. Again, with this kind of data storage system principle, we're just basically a black hole that you dump data in, and we're not the log source. We're not the source of the observability data, like with the exception of our own system observability.
Awesome.
Data. But log source is always something that you own, right? And it is different. This is like either some bare metal environment or some cloud environment, and any cloud, right? And the thing really is, you can instrument that log source so that it sends the data through the internet into the Opstrace instance.
Yeah, you don't even need Kubernetes, right? Let's be clear. Any Prometheus source, any Prometheus source.
Yeah. Okay. And this is a beautiful opportunity to actually talk, briefly about the APIs, right? So, I hope some of the people in the audience know about the Prometheus Remote Write API, because this is actually how in the Prometheus ecosystem metrics are pushed from one part of the system to another part of the system. This is just an HTTP request with a protobuf message in the request body, and that encodes the metric samples. And so after all, an Opstrace instance for metrics, like for ingesting metrics, it just exposes an endpoint that understands the Prometheus remote write protocol for metrics. So, and this is exactly how a foreign Prometheus instance can push data into an Opstrace instance. You can just configure the kind of the source side of things to remote write into the Opstrace instance. And for logs, it's exactly the same, just that the underlying binary message format understands logs and not just metrics. Yeah. And it is very easy to create an HTTP client that actually constructs these messages and sends them into the Opstrace instance. So you can even write your own custom log aggregator very quickly, actually. But the famous ones that we can easily integrate with FluentD, FluentBit, Promptail, those are kind of the main things that we work with to collect logs at the log source side of things and then push them out into the Opstrace instance. And for metrics, we actually only work with Prometheus to actually collect things at the log source and then push them out into the Opstrace instance.
Yeah. And over time, we're going to be adding more sources, right? Datadog is just an example. We're going to be adding obviously OpenTelemetry. We're going to be adding things like probably compatibility with OpenSearch, so that you can use things like FileBeat and others to send data there. And that'll depend on what our users want us to do first.
So like you said, when we integrate or add an integration or add a cluster, let's say we add a cluster. So the Grafana dashboards that you are saying, they are pre-built dashboards that comes out of the box?
Yeah. It's a good question, because I almost felt like this question will come and open a dashboard, that we actually use ourselves, to understand, how is this Opstrace instance doing? So this is the Grafana instance for the system tenant. And really the goal is to see, how is Loki doing in this Opstrace instance? And now here you can see, various things. Like, for example, the memory usage per ingesta, not going to explain what an ingesta really is, but it's a core piece of Loki. Actually, we invested already quite a bit of love into these dashboards to actually, be able to monitor the core pieces of Opstrace. And this is all built in and of course iterated upon, right? Far from perfect. Yeah.
And I'd add one more thing. When you press the install button for example, that generated the YAML for the logs or the metrics, we also install dashboards. There's a button that says install dashboard, and it will install some default Kubernetes dashboards. And over time, we're going to do the same for the CloudWatch things and other pieces, because we want to help people.
Right.
There are a lot of out-of-the-box dashboards that could be useful, right? Like, but then we don't prevent anyone from adding their own dashboards. It's still pure Grafana. And to circle it back to the beginning, the database, for example, the RDS database that we deploy is used as a backend for Grafana and our own configuration, right? There's no metrics or logs in there. It's purely, this is where the dashboards end up when you push them there. Yeah.
Okay, and also there is a Loki, you can search all the logs from the Loki, right? And you saw,
yes.
And you showed some of the keywords that were already there, like the namespaces and all these things. So they come also pre-built as part of when we do the deployment of the YAML file.
This is true. Like so in the Loki ecosystem, right? So log streams differentiate by label sets, right? So it's really important to set the labels at the log source, right? And for a Kubernetes environment, what makes sense, of course, is to set namespace and container name and pod name and these kinds of things, right? And for different environments, it might make sense to use something completely else, right? But yeah, for those pre-built integrations for Kubernetes, we actually set these meaningful labels at the source. And this is how I also, as part of the demo very early on, I discovered the Promtail log. I don't know if you remember, but those labels we actually set, But this is also an important insight, right? Depending on the environment that you're in, you actually have to invest a little bit of thinking work into how to choose your labels. There is no one size fits all solution, right?
Yep.
Okay, we have 3 minutes left. I think should maybe move to roadmap discussion.
Yep, absolutely.
Awesome. We can do this very quickly. We also give a little bit of hints to what we're doing. This is supposed to be easy. This is meant to become much, much, much easier, right? We want these things to really be usable for people who don't know anything about Kubernetes, who were just given, here's a Kubernetes cluster, please just instrument it and things like this. So that's one of the things. Invest in UX, invest in these things, and then also the various amount of, as I said, we don't support OpenTelemetry yet. We don't support, so this is one of the endpoints that we want to add. We want to add a solution for tracing. Tracing is something that is important, but turns out when we went around, people have much, much more issues with the basics, metrics and logs. So we started with the basics, but we haven't forgotten that in the future, we want to support things like tracing as well, in the same manner. Other things, if we look far down the future, we want to support other kinds of things like OpenSearch, because sometimes you want to full index search the logs, but it's expensive to put all of the logs into Elastic or OpenSearch, right? And so we think that we want to allow you to redirect a percentage of the logs into systems like this to say, oh, when there's this label available, I want to full text search it, right? And then much closer in the timelines of things to do, you saw that this uses Opstrace.io. We want to allow you to use any domain name, to use any authentication. This is for the advanced users a bit more. Authentication and domain names are something that out of the box is not easy for people. So we provided these Opstrace.io and Auth0 authentication through a little bit of magic, like JP said, but it's all in the code. And then over time, we want to make it purely configurable. I also talked about bounded configurations, how we make sure that things don't break. Things that haven't been demonstrated as a demo is there's an Opstrace upgrade command. We release a new version. We test the upgrade from one version to another. A lot more we want to put into the upgrade command. Eventually, if you go further down the future, why go back to the CLI to do an upgrade, right? Like the system should have a button and eventually auto upgrade, right? Like this is way down the future. And yeah, this is how we want to build this: more UX, more admin interfaces, more things to help with people with configuration, discoverability. Discoverability is tough. And yeah, that's the current state of things. Lots of big plans, but we have fun building it, and anybody can join. This is meant, by the way, we didn't say it once, but it's important to say, this is meant to be fully open source, and it's going to stay fully open source. There's not going to be any enterprise features or anything, because we have other ideas of how to monetize this. We're going to run this for other companies like we do today in their account. We, as the Opstrace companies, are on call for it. And this is how we can guarantee that we have another revenue stream and that we can keep this open. We don't think that it's worth building it so that there's like special features that are only available to paid people. So yeah, that's where we are right now. So I thought it was important to drop that at the end.
Yep, absolutely. Like I really like the ideology, and keeping it open source. The product has a very good strengths, and you can see in the comments like people will give it a try as well, which is really good.
Yeah, thanks guys. Thanks for expressing that. I was super happy to see these comments. Yeah.
Same here. Same here.
Yep. Even I'll also give it a spin, just because so you can have a centralized Opstrace cluster, and you can connect different sources of different integrations, and you can keep on sending metrics, and you can have different tenants for that, and you can visualize, monitor, and also like you said that it can scale well. So obviously you have done all the works and the integration so that it handles that sort of scale and amount of ingestion rate. Yeah, even I like right now there is a big set of configurations that you can do, but down the lane it will be based on the size that you chose. Like if you choose a small cluster, obviously you cannot have extreme super high ingestion rates. So those things also, I mean, making it all super simple for anybody who do not understand much of the configuration options, much of the how the integration works. That really makes sense, and I feel like there is a huge market for that. People just want to like you said, instrument the Kubernetes cluster or instrument XYZ. So people just can use Opstrace, and they can instrument whatever they have in front of them, and without even getting knowledge of that particular domain, which is even not required to be in a very expertise level. So people can focus on business logic more and less on the instrumentation part.
That's correct. Exactly.
100%, yeah. Thanks for the great summary, I must say. Yeah. Lovely.
One last thing I'd add is, to contribute, it's on GitHub. There's our website. You can join. We have a Slack where we chat, and we're open to anyone contributing.
Yeah.
This is it is not easy today because you have to launch it in a cloud account. But if somebody's listening to this, we can provide access to AWS accounts to help you with developing on this. You don't have to spend your own money if you want to help and come contribute. So
I want to encourage people to also use our GitHub discussions integration. So of course we have a community Slack, and there's GitHub issues, right? But for general questions, we have GitHub discussions too, and this is a great place to just ask anything. Yeah.
I think Slack community would be great. So I'm just dropping the link. So please make sure you join the Slack community, because that's where most of the developers would hang out, and would be answering your queries. And you can also, like JP and said like, if you are from the student community and you cannot pay for the AWS accounts or something, and you still want to contribute, write blogs and do some stuff around Opstrace, please reach out to them, and they would be happy to give you some free accounts to test out stuff, build stuff on top of that. So I think that's pretty amazing. I haven't actually heard about that before with some open source product, but they are doing it. It's completely amazing. So please make sure you take that opportunity and try it out, see what happens, and how you can improve, how you can contribute in any ways that would be there. I really like the ideology, like I said earlier. So that's pretty interesting, and keeping it open source, a big thumbs up for that. So keep doing the awesome stuff that you folks are doing. And I'm pretty sure that the community, whoever is watching now and will watch later, would definitely be interested in something like Opstrace solution. Yeah, you will see me around as well. So thank you, Seb and JP, for giving your time and explaining about the awesome things that you are working on.
Thank you so much, Sayam. Thanks, everyone.
Thanks, everyone, for listening. Yeah, much appreciated.
Thank you all, and make sure you subscribe to the channel so that I can keep continuing doing these stream with awesome people like JP and Seb. And tomorrow I'll be going live with founder of KubeCost, and we'll be discovering KubeCost, how it works, how well you can see what actually you're using in the cluster and what you are paying for. So that would be interesting as well. So tune in tomorrow 8:30 p.m. And if there's a timing issue, so I saw some of the folks were saying like they thought that the stream is at 8:30 because usual time is 8:30 p.m. IST, but that's where the bell icon helps. So please press the bell icon so that you get the notification as soon as the stream goes live. Thank you for tuning in anyways. See you tomorrow, and thank you, JP and Seb, for your time.
Thank you. Plus 100 for KubeCost. Awesome stuff.
Bye.
Bye.